Okay, we're going to do worksheet S7F, sampling with and without replacement. Okay, so let's do our warm-up first where we talk about rounding. So this first question says we want to round this to 3 significant figures. So the first 3 eighths are significant. We look here, the next digit is an 8, so because it's greater than 5, we round this 8 here to a 9. 3 significant figures here. So we've got our 3, the 7, the 4 are significant. This last digit here is greater than 5, so we round the 4 up, and we don't write another number here because if we wrote a 0 here, then this would be 4 significant rather than 3. Okay, 1 significant figure, so the 2 is the only significant number, and since the 7 is greater than 5, we're going to round this 2 up to 3. Isn't 27,000 pretty close to 3,000 if we use 1 significant figure? Next, question D. We want to round this to 2 significant figures. These 2 zeros are significant. So we look here at the 6, and since that's greater than 5, we're going to round this last 0 up to 1. This is one I can see a lot of students making a mistake on the real IB test. Square root of 62. We plug that into the calculator and we get this value. If we want 1 decimal place, we look here at the 8 and we can see that this is a 7. We round that 8 up to a 9. You may want to hit pause and check your work on these other answers. Okay, some samples of with and without replacement. You may want to hit pause and copy this down. With replacement, if we use 2 separate jars, or if we just pick a card, put the card back, and then that's with replacement. Without replacement is like, for an example, if we eat a gummy bear and now we've got 1 less gummy bear. That's without replacement. You may want to hit pause and copy this down. Okay, I used this tree to help answer example 15. You might want to use highlighters like I do because I think the highlighters really help clarify what's happening. This question says, I have a box containing 3 red, 2 blue, and 1 yellow marble. Find the probability of getting 2 different colors. Okay, if replacement occurs. So, 2 different colors. So I'm either going to get red and blue, red and yellow, blue and red, blue and yellow, yellow and red, yellow and blue. So those pathways, it's either 3 6 times 2 6, or 3 6 times 1 6, or 2 6 times 3 6, or 2 6 times 1 6, or 1 6 times 3 6, or 1 6 times 2 6. So these are the 6 different branches on the tree that we could use to figure out getting 2 different colors. And then once we figure out each of these values, we add the 6 different probabilities together to figure out the probability of getting 2 different colors. You may want to hit pause and copy this down. Okay. Let's look at example 16. This is a very good example. The bag contains 4 red and 3 blue marbles. 2 marbles are drawn at the same time from the bag. Determine the probability that at least one of them is red. So this, for example, is going to be the probability of 2 reds plus the probability of a red and blue, and then also the probability of a blue and a red. Okay, so probability of a red and a red is 5/8 times 4/7. the probability of a red and a blue is 5/8 times 3/7. The probability of a blue and a red is 3/8 times 5/7. Now, we started off with 5 out of 8 marbles. If I've taken one of the red marbles out, this numerator becomes a 4. And we also only have 7 marbles to choose from when we're doing our second thing. You know you've set up the tree right if these two things add up to 1, right? 4/7 plus 3/7 gives me 7/7. Same thing here. 5/7 plus 2/7 gives me 7/7. If I've picked a blue marble, that we have a 3/8 chance of getting a blue marble. And then if I go here, well, I've taken out one of the blue marbles, so now I've only got 2 blue marbles left out of 7. If I go this route, I still have the 5 red marbles, so it's a 5 out of 7 chance. You may want to hit pause and think about this and replay if you have any questions. If you don't simplify the fraction, I'll give you full credit still. Okay, let's look at this example here. 2 marbles are drawn in succession from the box. 2 of them are purple, 5 are green. Determine the probability that the 2 marbles are different colors if the first is replaced. So if the first marble is replaced, that means the denominator doesn't change, and so we had a 2/7 chance of getting purple. The next time we still have a 2/7 chance of getting purple. So these fractions don't change from the original thing because the first marble is replaced. Okay, so the probability of getting different colors, you're either going to have purple and green or green and purple. Okay, now if it's not replaced, once again the denominator decreases by 1. So if I had purple, if I've taken out a purple marble, now I'm only going to have 1 purple marble left. We still have 5 green marbles. Now I've taken out a green marble. Now I've got 4 green marbles to choose from. We still have the 2 purple marbles. You may want to hit pause and copy this down or check your work. Let's look at example 4. We've got 6 orange candy drops and 4 lemon drops. So we have a 6 out of 10 chance of getting the orange, 4 out of 10 chance of getting the lemon. After we've taken the orange gumdrop and eaten it, now I've got 5 out of 9 chances of getting an orange. We still have 4 lemon drops, so we have 4 out of 9 at this point. If I've eaten a lemon drop then instead, then I end up with 3 out of 9 chances of getting lemon the second time. Or if I get an orange, I have a 6 out of 9 chance because we still have 6 orange drops. So I've got all these different things. So what's the probability of getting orange twice? That's going this pathway, 6/10 times 5/9. If I go, the probability of getting lemon twice is going to be 4/10 times 3/9. The probability of getting orange and lemon is 6/10 times 4/9. And lastly, the probability of getting lemon and orange is 4/10 times 6/9. And so we end up with, if I go the blue route, the red route, the yellow route, and the orange route, those are all the possible branches. There are no other possible branches. If you add all of 4 of these probabilities together, you're going to end up with 1. And the reason is the 4 different combinations are the only possible combinations given the 2 events. You may want to hit pause and think about this. Okay, last page. You've got a bag containing 4 red and 2 blue marbles. 3 marbles are taken out in a row. Determine the probability that all 3 are red. So the tree we set up here is a little bit bigger. I'm going to zoom in just for a second. You can hit pause if you want to help you copy this down. Okay. Now, so the probability of getting 3 red is 4/6 times 3/5 times 2/4. Okay. Because each time one marble is taken out, so the denominator and the numerator keeps reducing. The probability of only getting 2 red is I can either get a red, red, and blue, or I can get a red, blue, and red, or I could get a blue, red, and red. Those are the 3 possible chances for getting 2 red marbles. So 4/6 times 3/5 times 2/4 is this one here with red, red, and blue. 4/6 times 2/5 times 3/4 is red, blue, red. And this last one is 2/6 times 4/5 times 3/4 to get blue, red, red. Okay, add those together and we have our probability of getting 2 red. Now the probability of at least getting 2 red is the probability of 2 red plus the probability of getting 3 red, adding those together. You may want to hit pause to copy this down. Okay, last question. We've got a container that holds 3 red, 7 white, and 2 black balls. A ball is chosen at random from the container and is not replaced, and then a second ball is chosen. So what is the probability that one of them is white and then the next one is black in any order? So we want to find out the probability of getting a white one and then a black one, or a black one and then a white one. The first thing I did was I set up my tree. So 3 red, 7 white, 2 black, that's 12 marbles total. So we have 3 out of 12 chance of getting red, 7 out of 12 chance getting white, 2 out of 12 chance of getting black. Now from here I could get a red, white, and black. From here I could get a red, white, and black. From here I could get a red, white, and black. So if I've got red, then the next is going to be 2 out of 11, or 7 out of 11, or 2 out of 11 for getting red, white, and black. The denominator has decreased, and the numerator has only decreased for the red only here. Now if I've gone this way, I've picked white first, so the numerator is only decreasing here for white, and the denominator is decreasing for all 3 of these. And then if I've gone here, if I've picked blue, once again, the denominator is decreasing by 1, and the numerator is only decreasing here for blue because we've picked blue, so now we have 1 less blue. Okay, and we add these together and we get this answer. I hope this helps you with your notes.